All right, good day. This is Surdman Academy. So in our last video, we treated direct variation. Now we are going to go into inverse variation. Now, when we talk about inverse variation, this is a type of variation in which the two quantities involved do not increase or decrease at the same time. What does that mean? It means that when one is increasing, the other is decreasing. While when the other one is increasing, one is decreasing. So that is all about inverse variation. Unlike direct variation, you can check it up. Unlike direct variation, which shows that the both are increasing at the same time. So in this inverse variation, we are given this question. Given that y varies inversely as the square of x and y equals 8, x equals 2. Find the relationship connecting them. Calculate the value for y when x is 6 and x when y is 1/2. There is something you need to understand. Another thing you need to understand about variation. Whether you are solving for direct variation or inverse variation or joint variation or partial variation, any type of variation you are solving for, first of all, you must get the relationship connecting the whole variable. So whether you are solving direct, you must get the relationship. So even without being told, because some questions they might neglect this, find the relationship connecting them. They might decide not to ask that and just go straight to calculate the value of y and when x is this. So even though you are not being told to find it, you must find the relationship connecting any variation or any variable you are solving for. If you are solving under direct, you must find the relationship connecting them. If you are solving under inverse, you must find the relationship. Same thing with joint and partial. So with knowing this, now let's get down to this and break this down. So we talk about the solution. Let's see the solution here. We are being told that y varies inversely as the square of x. So thereby we're gonna have then y equals k over x, whereby we introduce the constants. Once we remove these variation sign, we introduce the constants, which will give us, okay, let's make it more clear, which will give us okay, let's see how we can make this more clear now. So once we remove these variations and we put a constant, which is y equals k times 1/x squared, which will now give us k over x squared. So we're gonna have y equals k over x squared. So from the question, we are given x to be 2 and y to be 8. That's for the first start. So x to be 2, y to be 8. Now y, you have your 8k over 2 squared, which will give us, when you cross multiply, you have k equals 8 times 2 squared, which will give us 8 times 4, which will give us 32. So this is our value for k. Let's take this k back to the original equation. So if you are taking it back, we're gonna have y equals, we now substitute for this k. We substitute for this k with this 32 now. It now becomes equals 32 over x squared. So now this becomes our relationship. So this becomes what? Our relationship. Now let's get down to solving. The first one, we are told to find y when x is 6. So we have y equals 32 over 6 squared, which will give us 32 over 6 squared. That is 6 times 6 is 36, which if you divide it, you're going to have 8 over 9. And that is it. Now the second one, either you have this 8 over 9, or you have it in decimal, which can also be 0.8. It can also be 0.88. Now the second one says we should find for x when y is 1 over 2. Now using the same equation, remember we still have the same equation. Sorry, this is 32 over, we are looking for x this time. Okay, so if you have to substitute here, you are told that y is 1 over 2, so that 1 over 2 equals 32 over x. So when you cross multiply, you have x equals, so this is x squared. So this will give us x squared equals 2 times 32 give us 64. So x will give us this square crossing over here becomes square root. So it becomes square root of 64, which 8. So, and this is how we solve for the variation. I guess if this is very clear. So if you understand this, try this next one. All right, try this. God bless you. See you next time. I still remain Surdman.